Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, I'll go through an example of simple linear regression. This is a study that I've made up and generated data for using the following scenario. Let's say a researcher conducts a smoking cessation study to determine whether the number of years a person has been smoking influences the number of cigarettes they smoke following participation in some treatment study that we've designed. The participants report their smoking history at the start of the study, how many years they've been smoking. And then they record the number of cigarettes that they smoked per day during a 1-week period after 1 month in the program. This is what the data look like. We've got 15 participants, and for each participant, we have some measure of the continuous X variable, which is years smoking, the measured predictor, and the continuous measure of number of cigarettes smoked per day, or smoking intensity, as the outcome variable. So each person has data on each of these variables. This is what the scatter plot looks like for this data. So in this plot, the number of years smoking is the predictor, so it's on the x-axis, and the number of cigarettes smoked per day after treatment is on the y-axis because it's the outcome. I've shown you a fit line through this data, so we can see just from looking at the scatter plot that it looks like the two variables are related in some way. The reason the data points, the scatter plot points, are aligned the way they are is because, if you recall from the previous slide, we have measured years smoking and number of cigarettes smoked per day as whole numbers. So it's a continuous scale, but we don't have that variability we'd see if we had some sort of scale with decimal places. That's why the values kind of line up along those lines on the axes. So in order to conduct regression in SPSS with this data, we would select the Analyze pull-down menu, and we would go to Regression and select Linear because we're doing linear regression. And when we do that, we would get this pop-up box, and we would be able to select each variable and put them into these boxes. So the dependent variable, or the outcome, is the number of cigarettes smoked per day. And the predictor, or the independent variable, is years smoking. So I've put those into the boxes, and then I paste the syntax, and this is what that syntax would look like. Now let's talk, before we get into looking at the output, let's talk a little bit about the estimates of interest. So you'll recall from the last lecture that the two parameter estimates that we are interested in from this equation are the intercept and the slope. Now, these are the formulas for the intercept and the slope. So let's focus on the slope first. The slope is essentially the sum of the products, which you'll recall is the numerator of the covariance, divided by the sum of squares for x. So remember, the sum of products is essentially the sum of the difference between each x score and its mean and each y score and its mean. Those multiplied, and then we sum those values. And this equation is also equal to the correlation between x and y multiplied by the standard deviation of y over the standard deviation of x. So if we divide standard deviation of y by standard deviation of x, and then we multiply that value by the correlation between x and y, this gives us the slope estimate for this regression equation. Now, the intercept is a little bit easier to understand and calculate, because once we've calculated the slope, if we have the means of y and x, we can calculate the intercept. So remember, the intercept is the predicted value of y when x is equal to 0. And to get this value, we can essentially multiply the calculated slope by the mean of x, and then subtract that value from the mean of y. And this will give us the intercept. So now that we've looked at these formulas, let's take a look at the example output and see how we could actually calculate these estimates. This is some of the output that comes with the regression procedure in SPSS. So it actually prints out the descriptive statistics and the correlation between the variables for you. So I've highlighted with pink boxes the values that we need to plug in to calculate our estimates. So let's focus first on the slope. And we have the correlation here between X and Y. So we can see that the correlation between years of smoking and number of cigarettes smoked per day is 0.426. So we plug that value in for R, and then we need the standard deviations of Y and X. So the standard deviation of Y, or number of cigarettes smoked per day, is highlighted in pink in the on the right top cell of the descriptive statistics box, and it's 5.196. So we plug that into that numerator there. And then in that lower right box in descriptive statistics, that gives us the standard deviation for X, or years of smoking. And it's 3. So we plug that in. So essentially we divide the 5.196 value by 3, and we multiply that value by 0.426. And this gives us an overall value of 0.738. That's telling us that our slope estimate is 0.738. Now, once we have that slope estimate of 0.738, we can use that to calculate the intercept estimate. Now, in the left column of the descriptive statistics box, I've highlighted the means of the X and Y variables. So the mean of Y is 10. And the mean of X is 8. And when we plug those in to the equation for the intercept estimate, along with the slope estimate, that gives us an intercept estimate of 4.095. So now let's talk about the interpretations of these values. As I briefly mentioned before, the slope is simply the slope of the regression line. This estimate is essentially telling us the amount that Y will change for a 1-unit change in X. And B0, the intercept, can be thought of as the point where the regression line crosses the Y-axis if we look at the plot, at a plot of the regression line. It's also the value of Y when X is equal to 0. Now, using our smoking example, we can basically use these interpretations to interpret those values that we calculated. So let's here start with the intercept. The intercept was 4.095. Now, this is telling us the predicted Y when X is equal to 0. So for our example, it's telling us the predicted number of cigarettes smoked per day for an individual with 0 years of smoking, because X is years of smoking. Now, everyone in our study has been smoking for more than 0 years because everyone is a smoker. It's a smoking cessation study. So actually, in our example, this is a nonsensical estimate, right? We don't care about the predicted number of cigarettes per day for an individual with 0 years of smoking. It makes no sense. It's impossible. But that's how we would interpret it in this example. So here is an interesting point to think about, is that although we can calculate these values, the intercept is not always meaningful unless we transform the data in some way. And we'll talk more about that in later video lectures. And if our population, for example, if 0 isn't an actual possible value for the population on the Y variable, then our or on the X variable, then our intercept is not going to be interpretable at all. Now, the interpretation from our example for the slope coefficient, which is 0.738, would be, remember that it's for in every 1 unit increase in X, the predicted increase in Y. So 0.738 essentially means that because our X is scaled in terms of years of smoking, that for every 1 additional year a participant has been smoking, we would predict a 0.738 increase in the number of cigarettes smoked per day. Essentially, that's indicating to us the positive relation between years of smoking and the number of cigarettes smoked per day. So the longer a person has been smoking, the more cigarettes they smoke per day. And this is essentially giving us a numeric value on that relation. Now, the SPSS output actually also gives us these coefficients. So I've shown you the formulas to calculate them and how to calculate them. But if we run this in a computer program, we don't have to calculate the estimates. We can actually get them from the output. And I've highlighted where they are here. So you'll see that the first row in this table, it says constant, and that essentially means intercept. Constant means intercept, and that's that value that we calculated, 4.095. And in that second row, years smoking, remember that years smoking is the predictor. This is telling us that this is the predictor on the dependent variable outcome, number of cigarettes smoked per day. And so we know that that slope estimate is 0.738. So this is where we would find those coefficients in an SPSS table. So this concludes the second lecture on linear regression. At this point, we have talked conceptually about linear regression, and I've showed you how to calculate the two estimates of interest, the intercept and the slope. I've also shown you how to run the analysis in SPSS, but I haven't really talked about actually determining statistical significance for this model. So in the next lecture, I'll describe significance testing for linear regression, and we'll talk about the hypotheses, and we'll also talk about proportional reduction in error in terms of the linear regression model.